Today we will be doing a problem from Exam 1, Part 3, Question 5C. First step we can take to answering this problem is by reading it. So, the problem is asking to find the amount of force from Q2 on Q0 with the following information. We can now start step 2, which is asking us to identify the what. So what do we know? Well, we know that the charge of Q2 is positive 7.5 times 10 to the negative 4 coulombs. We also know that the charge of Q0 is equal to negative 1.1 times 10 to the negative 4 coulombs. And then we also know that the K constant is equal to 8.99 times 10 to the 9 SI units. And now we can start the third step, which is identifying the correct equation to use. So for this problem, we can use the equation that states f of c is equal to the K constant times the absolute value of Q1 times the absolute value of Q2 over r squared. However, we want to find the force between charges Q0 and Q2. This is why we will use the equation f of c equals the K constant times the absolute value of Q0 times the absolute value of Q2 over r squared. And now we can put in the numbers from the what do we know section. It is important to note that I am referring to Exam 1A, Question 5C. This is why we aren't necessarily told a distance in the numbers above. However, in the exam, we are given plot points for a graph that refers us to the distance. So, r squared is really equal to 1 meter squared. After plugging these numbers into my calculator, I am given the number 741.679. However, we can turn this into scientific notation, which basically turns f of c into 7.416 times 10 squared newtons per coulomb. And that, my friends, is our final answer.